Hello everyone. What we're going to do today is the operation of the 3D printer. First, we will turn on the power. When you turn on the power, you will see that the light at the front is lit. There is a red light, which means that we have not performed initialization. So we need to press down this button and hold. Wait for the beeping noise to stop. Then you can remove your hand. What is the 3D printer currently doing? It is currently carrying out the initialization process. It needs to reposition the 0 point of the X, Y, and Z axis. After it's finished with positioning, we can then connect to it and operate it. When it's performing its positioning, this machine has this characteristic. When positioning, its touch sensors may not be very sensitive, so it sometimes makes sounds, but it doesn't matter, let it continue, and it will finish. The positioning is finished. Once it's done, the light will turn blue. Then we can use our computer to open a software called Up Studio, which is the software used to connect to it. This software is responsible for two things. First, we can use it to operate the 3D printer. Second, it can convert our drawing file into G-code. To allow its processing, let's open the software. Let's click on Up Studio. Once the home screen is loaded, we can click on this Up icon on the left to go into the operation screen. Let me first introduce you to this interface. This top row is the information row. The first line tells us the 3D printer number connected to our computer. This number represents this machine's identification number during printing. We can add other printers. This printer can also use Wi-Fi for connection. There are these two methods. Later, during our operation, we will be using a wired connection with the USB cable. If you don't want to use the USB cable, you can also connect to it using Wi-Fi. Before we start with the printing, before the drawing file is imported, what we first need to do is to check that the 3D printer is working properly. The plastic material that we're going to use is PLA. Another commonly used material other than PLA is called ABS. A disadvantage of using PLA is that it ruptures easily due to moisture. Therefore, if you want to use PLA material, I suggest that you perform an action, which is to extrude a bit of the material out. Let's go to the maintenance option and click on Extrude. Let it attempt to extrude. During this stage, at the top of the screen you can see that the heating head's temperature is rising. 40, 45, it's rising rapidly. At this time you will notice that in front of the machine's panel, the lights will flash blue and red, which means that it is currently heating up. It will heat up until it reaches 200 degrees approximately before it starts extruding material. If you're the first person using it today, you must first perform maintenance to check that our 3D printer's extruding function is working properly and smoothly. On this maintenance window, there are a few options. The first one is print board. We won't change the setting. We'll choose this plate. For the nozzle diameter, there are three types. We will choose the 0.4 mm one. Next is the preheat time. These are default values. We should not change them. Then there is a material section, which is the PLA material that we'll be using. Different materials will have different parameters. You can see that it is currently extruding the material normally. It will test extrude a section. Before operating, you must ensure that its extruding action is normal before you continue. If the extruding is not normal, you need to pay attention. The line might have broken off, so it cannot extrude normally, so you need to pay attention to this. It beeped again, which means that the action is finished. Remember to take the extruded material and throw it in the bin. Don't litter. Other than the extrude option, there is a withdraw option which withdraws the material. Why does the material need to be withdrawn? Sometimes you need to change colors. Then you have to withdraw the material. Now we will withdraw the material. When your printing is almost finished, you need to withdraw the material. Withdrawing the material also requires heating up. When you hear the beeping sound, it means it's heating up. We can take a look at this. The material is slowly being withdrawn. Once the material is withdrawn, we need to learn how to deliver the material. The reason is because you need to change the materials or the material broken off. You have to learn how to change the material. When delivering the material, remember to make a diagonal cut at the end. Why do we need to cut it diagonally? This way it is less likely to get stuck when delivering it. Let's perform the extrude action again. Click on it. When you hear it making a beeping sound, you have to wait, because it means that it is currently heating up. The current heating temperature will be shown on screen. When it reaches the required temperature, it will make another beeping sound to notify you, and then we can proceed with the delivery of the material. And the material will be extruded down. You can use your ring finger to feel the material being squeezed down. For the first time delivery, we recommend do it twice in succession, because during the previous withdrawal action, there is probably a gap inside to ensure that the material is delivered properly. The best would be to deliver the material twice during your first time delivery. Let's extrude a second time to ensure that the whole heating tube and the passageway is filled with material and has no gaps. While waiting for the material to be delivered, we can do the next step. We can close this window. Next. There is a plus icon here which adds in the object to be 3D printed. When you hear the beeping sound, it means that the task is finished. Remember to remove later. When you use the printer, it will interfere with the production of your part. When importing the object, we can left-click the mouse and slightly move this around. Also at the bottom right corner, we can use different angles to observe it. You can look at it from above or you can move it around. When printing, you can choose the direction you want to print, which is related to the production speed and the strength setting. You can decide the direction of the printing. In order to save time, we want this object to lay flat on the surface, so we can click on this rotate tool on the side. There are several tools on this wheel that can be used. Let's first check out the rotate tool. The X, Y, or Z axis will choose the Y axis, rotate an angle of 90 degrees, and it will lay flat on the surface. Let's have a look. Suppose that after rotation the object is floating. What we need to do is to automatically place it. Once the object is placed automatically, it will lay flat on the surface. There are some other tools here, such as View or Display Mode cross-section. You can try this out later. There are also other tools over here, but we will only talk about the tools commonly used. If you don't want to go back, to the modeling software to perform this object scaling. There is also a scaling tool in here to configure. After placing this object, we'll click on Automatic Placement. You can choose the printing direction. Next, there is a print setting on the left side. Let's click on it. There are some printing settings shown. The first one is the layer thickness, which refers to the thickness of each layer that is stacked up during the production process. Different thickness will affect its processing speed. It is recommended that if you have no expectations towards detailed quality, we usually choose a thickness of 0.25 or 0.3. If the surface is more complex, we can set it to 0.1 millimeters. This way the thickness will be thinner, but because each layer is thinner, its processing precision will be higher. Next is the infill. There are several options. If you want higher strength, then the infill density will need to be higher. For example, there is 20%, 65%. This will affect the density of the infill. This is up to your needs. Normally choosing an infill of 20% is enough. If a higher strength is needed, we can set a higher infill density. Next is the quality. The default setting is normal. If you want a faster or higher quality printing, there are other options. For this nozzle offset, we basically set this to 0 because there is no height problem, unless you have a special need. Otherwise, we don't change the setting. Next is the unsolid model. It is ticked by default. Next is no raft. When we are printing an object, if you want a better quality and avoid any complications during the printing process, it is recommended not to tick this option. If you want a faster production speed and you're sure that the base that is processed, as well as the heating head's height, because when printing without raft, scraps will be generated and it will take a longer time. However, it is suggested not to tick this option because this way the printing success rate will be higher. Next is the support. If the object you want to print is as simple as this, there are no suspended structures present, then the support is not needed. If there are suspended structures, then you'll need to think whether this option is necessary or not and not tick this. If your object is suspended, by no means tick this. For objects like this one, the software can actually evaluate. For such a simple object, it usually does not have support. It will make no difference whether you tick it or not. However, there will be a difference for the case of objects that are between needing and not needing support in the center. In that case, you'll need to think about it. Our default is to not tick it. Next, we can have a preview. The printed result will be like this. The part at the bottom is what we call the raft, and the printed part is like this. Once it's done, you can drag this bar and see the situation of each layer. It allows you to have a preview. After the preview, we can go back to the main screen. Let's exit the preview. After that, you can print it. Let's print it first. When printing this object, you must make sure that there is someone present. Why? Because the 3D printer is considered a heating device after all. If any problem occurs, someone needs to be on standby for immediate action. Secondly, during the processing of this object, the most important thing, the printing of the base. The base is very important. If the base is stable enough, the printing of the incoming part will have no problems. When printing, you must check whether its printing situation is good. If the situation is not good, that is, the printing of the base is not good, we must recalibrate the base plate and the height. We will talk about this later. At this time, you will see that the temperature is rising. The material we chose is PLA. Another material used is called ABS. If it is an ABS material, the base plate needs to be heated up. Since we're using PLA, so the heating of the base plate won't be necessary. In the beginning, there will be some pre-extruded material, which can be removed because this excess material may get stuck inside and interfere with the processing of other parts. We'll use our hands to remove it. Next, we will print this. The printing speed will be slower because we want to ensure that it's printing correctly. At this time, if the nozzle's height is set wrong, it may end up scratching the heating base plate. So we will do this slowly so that you have time to remedy it. After the base is finished printing, its processing speed will go faster. At this stage, you will need to make sure that each extruded section is laying flat on the heating base plate. If the printing process has begun, you can close the software because the G-code has already been sent. So if you close the software used to operate the 3D printer, it won't matter. Leaving the software open also has an advantage. You can know how much time is left. For example, it shows at the top that the remaining time is 6 minutes and the task will be completed. After the printing is complete, remember this: if you want to turn off the machine, you must pay attention to one thing. This machine has a very peculiar characteristic. When you turn off the power, the head will fall off. Because there is no self-protection mechanism, the motor won't hit the brakes. So you need to hold the head and then turn off the power. Then slide this head back. This is quite peculiar. Next, this scraper is a bit like a knife's edge. It has an open edge, so you need to be careful. When pulling this plate out, don't just scratch the coated surface. This coating is actually for a better adhesion, so avoid scratching off the coating. Use the scraper gently, because when we were setting the height, we set it to just right. You just need to slightly push this in horizontally. You can try the posture. Push this in horizontally, and then pull it up and it will come off. After it's removed, you can then peel off the bottom layer. And it's done. Hello everyone. What we will perform next is the height calibration of the heating head. Why do we need to calibrate? For the heat up process, if you use it for a long time, you will notice that when you're printing the part, the adhesion between the printed part and the heating base plate is not good, which means that your height is off, so you need to do calibration. Next, we will click on the calibration option in the control bar. Once in, our height setting from last time was 180.8. In the same manner, we will use this range to recalibrate. Let's move this to this position 5, which is at the center of the heating base plate. There are several ways to calibrate. You just need to learn the most basic method. For a more complex calibration, you can ask the teacher to perform a more in-depth calibration. After we move to the position 5, we can set this up to 180. We'll key in 180 and press enter, then it will move near the 180 mark. While it moving, let's briefly describe the calibration method. We will place a sheet of paper between the heating head and the base plate. The heating head and the base plate should not touch. So we'll first use this piece of paper to feel the position of the heating head and the base plate. Such as here, it is easy to move the paper because the height is set higher than last time, so there should be no friction. We'll use this piece of paper to move within the gap between these two things. If you feel that it's slightly stuck, the height is barely higher than the thickness of the paper, then that's the position we need to measure. We use this sheet of paper as some sort of sensor. During this process, you can continuously operate the height of the heating head, and you slowly increase it. For example, now I increase it by 0.1. The sliding seems alright, then you gradually adjust this up. During this process, you increase the height while also sliding the sheet of paper. Just keep moving it. Just keep moving it. Now you start to feel the paper is starting to get friction. Your hand can sense it through the sliding. At this time, you move up again, and you'll notice that there's a lot of friction when sliding the paper. Then we'll lower back the height, back one increment. The reading we obtained is 181.7. We will take this value and subtract it by 0.5 to get the real height we need. We use this piece of paper for the calibration. When you start to feel friction between these two, the height obtained will then be subtracted by 0.5. Let's set this to 181.2. We'll set the nozzle's height at 181.2. Next, we will press confirm, and the height of the nozzle will be corrected. Let's operate it. Press confirm. Once confirmed, this window will close. Let's click on calibration again and check if the height has been modified. It has been changed to 181.2. So we'll press confirm. We can then continue with the next task. Hello everyone, today there will be operating the laser cutting machine. First of all, we need to turn on the power in the following order. After that, we need to make sure that this water chiller is turned on. We will obtain a water temperature. Next, we'll turn the switch for the laser cutting machine's power. After this is turned on, the system will initiate. We can pull this up first. Later, during the laser cutting process, this should be closed. After operating the laser cutting machine's hardware to a certain point, we'll be operating the software. Let's go to the desktop and open the RDWorks software. We'll go into this interface. This interface looks like it is a drawing software. The drawing capabilities are quite basic. If you're interested, you can check out the user manual. Now we are going to operate the laser cutting machine. First, we need to import the drawing that we want to process. We can only use the import option and cannot use open file because the file format is different. We placed two DXF files at the desktop. Let's open this file. When it's loaded, we can use the scroll wheel to adjust it. When the arrow cross cursor appears, we can move the drawing. Why do we do this? Because when we import the next file, it will also show at the center. So we'll move aside the drawing that's already imported. Next, we will import the second drawing. Once both files are imported, we can place these two parts to be processed closer together. When it's done, we are going to do the laser cutting. The laser cutting will cut these contour lines. When working with different plank materials, we'll need to consider the processing power and speed. In principle, it'll vary depending on the different machines. This laser cutting machine used in school has 80 watts of power. So for the manufacturing process, the material we most commonly use are wood planks 3 mm and 5 mm thick. For this demonstration, we will be using a 3 mm wood plank. When cutting this, there are some lines that need to be set to different layer colors. Why do we need different layer colors? Because the processing parameters are set in these different layers. First, for this A1 letter, we will have a different processing method. We only want to have an engraving effect. So we will choose this color, click on it. The lines will change to a different color. When doing this, you will notice that a second layer with green color appears. Select it to go into its settings. Its processing speed is 200 and the power is 25. Here you will notice that it's different from the black color's settings. The speed is much faster. It's 8 times faster, while the power is lower. When processing, this will result in not being able to cut through the plank and can only leave an engraving effect. This is used in lines for marking. Press confirm. The black lines are used for cutting. However, when we are processing the plank material, we tend to leave the outermost contour for last. We'll click on these two lines to make them turn into red, and we'll process this last. Why? Because our wood plank may be a bit warped. If you begin the processing by cutting the outermost segment first, it may fall off, and the original height setting will be off. Our habit is to leave the outermost contour shape to be cut last, such as these lines selected in red. After selecting these lines, we will choose the red color option. Click on it. You will see that there will be 3 layers. Let's check the first one. To explain to you once again, the first layer is black. It is placed at the top, so its processing will be first. The speed is set to 25 and the power is 75. This processing setting is for 3 mm plywood. For 5 mm thickness, we basically tend to adjust it this way. We keep the power fixed at 75. The restriction for this machine is not to exceed 80% of its maximum power. If you exceed the limit, the life cycle of the laser tube will be shortened. Therefore, we keep this power fixed and adjust the speed. The thicker the material is, the slower the cutting process should be. For a 3 mm thickness, we use 25. So for a 5 mm thickness, we can calculate the speed in a proportional way. Your approximate calculation should be around 10 mm per second, which should be suitable for 5 mm thickness. Then we can make an estimation this way. Of course, this is spoken from experience. It is still up to actual processing to know for sure. Press confirm. For the last processing step, we will go into the settings of this layer. The parameters for the red layer is the same as the black layer. Here we have the laser cutting processing method. There is a total of 4 types: scanning, cutting, punching, and lining. For our processing, we will mostly use materials for robot part. We won't have the chance to use the other methods in our processing, so we won't be explaining about them. I accidentally selected the wrong laser method. Scanning will fill the whole layer. In the processing method setting, we selected the wrong one. Let's change it back. We must choose laser cutting and press confirm. Next, let's have a look. The colors are correct. There is a path. Optimization option. Why do we need path optimization? If you don't select this option, when you're laser cutting, for example, the hole at the top left corner is cut, and then it will go to the bottom right corner. This is highly inefficient, so we'll use path optimization for our cutting, and it will find the path closest for it to process. The adjustment of the parameters are more or less like this. Once we're done, remember to press download. Once our processing parameters have been set, we can download our drawings to be processed into the laser cutting machine. We'll click on Download. It will ask you to input a name. We will use the default name. Next, it will ask if you want to overwrite the file. Click on Yes and overwrite the old file. Now the download is successful. If the download is successful, we can go to the laser cutting machine's operating interface to operate. Next, let's take a look at this part. Let's take a look at this screen. First, we will operate the laser head. We will move the laser head to the upper right corner of our workpiece. When operating, we will set the top right corner as the point of origin. Then we will take this tool, used for height calibration. Inside this laser head, there is a convex lens. It needs an adequate focal length to cut the wood in order to have the best efficiency. The focal length of this machine is 5 millimeters. As the most appropriate distance, we need to grab the triangle ruler with scales on it and check that it is at a 5 millimeter height. If it's not, we can use the Z plus and Z minus buttons on the control panel to adjust the height. After you adjust the height, use the triangle ruler to measure it again and confirm the height. Adjust it to an adequate height and you can put the ruler back. After our data is transferred to the laser cutting machine, we can place the workpiece that we want to work on. The workpiece we're going to use today is a plywood. It is 3 millimeters thick. Next, we will move our laser head to the upper right corner of our workpiece. The point of origin is set at the top right corner of our workpiece. We can use the X and Y axis buttons on the control panel to move. You need to press and hold. After moving it to the top right corner, we need to check the distance between the laser head and the workpiece, because there is convex lens inside that will focus the laser beam. When the laser is shot out, it will converge at this focal point. So it requires the use of a convex lens to focus the beams. The focal length is 5 millimeters. There are different scales on this ruler. This one is 5 millimeters. We need to have a spacing of 5 millimeters between the laser head and the workpiece. We can use the Z-axis buttons on the control panel, Z plus to raise the platform, and Z minus to lower the platform and move it. We'll come back here and adjust the height. This is to lower the platform. Let's demonstrate again. We'll raise the platform. After adjusting it to an adequate height, you can move the ruler in and check if the height is around 5 millimeters. You can have a look. This is the height. There is a scale which means that it has a 5 millimeter spacing. We can then put the ruler away. What we need to do next is this. There is a button named Origin. We will set this position as the origin point. Press the Origin button. Next, we're going to load the file that we transferred. There are many files uploaded into the machine. We'll choose the file named default that we just uploaded. Then we press Confirm. On this screen you can see the parts you want to process displayed. There are 3 layers. The processing path will be displayed here. After that, let's move on to the next step. Once the origin is set, I will execute this frame button. I will check the maximum range of the processing. We'll execute this once for you to see. What is this action confirming? It will confirm if the area on the workpiece is enough to process our parts. and it can ensure that during processing, it will not exceed the area on the workpiece. Once it's done, remember to close the hatch. This machine has a protection mechanism. If this hatch is not closed, the laser will not be shot out. It will not emit any laser beams. Before starting this, you must check if the water chiller and the suction blower are turned on. These two things need to be checked. See if the water chiller machine is on, and if there is an air blowing sound. The main reason for the air blow sound is that when the laser is cutting the workpiece, laser cutting is a high temperature processing method. When it contacts wood, it may catch on fire. When it catches on fire, it can immediately be extinguished. During processing, there will be a blowing sound if it catches on fire. The reason is mostly because you forgot to turn on the air blower function. Also, let me explain this. When you are operating the laser cutting machine, you must be near the machine, because it is quite dangerous if it catches on fire, and you need to deal with it immediately. That's why there is always a fire extinguisher nearby. Let's process this. We'll press the reset button. And we can take out our parts. After taking our parts out, the next step is to use a vacuum cleaner to clean it up. We can now close this.